when GIS stands alone, kind of like business stay behind.
That line stopped me in my tracks, and it perfectly captures the conversation you're about to hear. What happens when spatial data finally breaks free from the silos we've kept it in for decades? In this episode, I'm joined by Javier de la Torre, founder of Carto, board member at the OGC, and one of the people at the center of modern geospatial's transformation, and one of the first people in geospatial I met in New York City. From biodiversity research to building one of the most well-known spatial platforms on the planet, Javier has seen the industry evolve from every angle.
On average, like GIS professionals actually earn less money than professionals in other analytics careers.
We kick things off with how the two of us met, then dive into the heart of a long-standing issue in GIS, the isolation of spatial data from the rest of the analytics stack. Javi lays out how we got here, what it cost the industry, including career growth and compensation, and how new formats like GeoParquet and Iceberg are unlocking a completely new future.
The way I like to say that this is finally making geospatial data be free, because it's no longer kind of like trapped into specialized formats that only few people can get access to.
If you've ever asked why spatial data can't just work with the rest of your stack, or what it would mean to treat spatial data as a first-class citizen in analytics, this is the episode for you. The future is spatial, so let's get into it. Yeah, Javi, I mean, I know a lot about you, but why don't you give a little intro for anyone who might not?
Hi, Matt. Yeah, I do know also a lot about you. So yeah, maybe I can tell a little bit a little bit of an intro also connected to you, because we've known for a number of years, and it's a pleasure to be here. So my name is Javier de la Torre. I'm the founder of Carto, and I had the pleasure to actually work with Matt for quite some time. I remember still first time when you and I remember still the walk in Brooklyn where you were telling me about your passion around cartography, especially around urban transportation maps, and I was like, oh, okay, well, that's something that we definitely can share. So yeah, but I mean, yeah, now I'm as I said, founder of Carto. Also heavily involved on standardization, so I'm part of the board of OGC. I'm also very interested in everything around environmental kind of climate change, biodiversity. My background actually is on biodiversity informatics, so I used to be a scientist working on these fields, and that's how I got my passion into geospatial. So you will see, me kind of interacting a lot around the geospatial industry, its usage for environmental type of use cases, and then overall, how we can expand the usage of geospatial on society. Very passionate around that.
Yeah, well, I mean, I think we first met in New York. When I think, gosh, it was 2012.
Yeah.
I think you were still working in Soho, or at the time, and I mean, things have changed a lot since then, right? I mean, that's at the time from when you're building out Carto, or at the time Carto DB, it's really evolved into much more of a analytics platform, and I think that's something I'm seeing across the industry, is this shift into geospatial analytics and things like that. That being said, there's still this concept that I know you've talked quite a bit about, and I'm hearing, and I'm seeing all the time around this data silo around geospatial or GIS, or any spatial data. So let's start there. Why is there a data silo in our industry? Why is our data not sitting alongside of other things? And how did we get here today, at least from your perspective?
Yeah, sure. Well, I mean, the geospatial industry has existed for a long time. I mean, you can think about, we've been making maps for our entire history, right? But when it comes to the digitization of it and the invention of, the digital geospatial, or mapping industry, and then geospatial, in a way, I mean, it kind of evolved a lot on its own, and it's so rich in a way, our industry, that we've had to create a lot of formats and specialized products, software, to work, to make maps. But fundamentally, if you think about it, geospatial is a subset of the broader kind of like, say, analytics, right? But it was so hard to work with the spatial data that you ended up, having in a way to create all these specialized, as I said, like software and then formats, to be able to work with that. And for a long time, our industry has been able to capture and specialize a lot of, like experts into so-called GIS professionals that, you will go to school, you will learn geography, you will learn GIS tools, and those will then become kind of like the tools that you will use for your entire life, right? And in a way, that mode has made that, like we were also kind of, like isolating ourselves from the rest of analytics, right? So you had, like GIS professionals that, although they were doing a lot of, like things like statistics and so on, they were doing it within GIS programs, not necessarily connected with the rest of analytics. And the result of that is, like it's kind of like a large industry that, if you think about it, should be part of a wider kind of like analytics community. But because of, like the history, like, I don't know, if you think about like something like GDAL, you probably can count, like more than 200 formats, we've been creating over the years to kind of like solve spatial problems where kind of like needed in a way. And like those kind of like new specialized formats and specialized kind of like software and so on has made that, that we ended up kind of like creating our own silo from the rest of the analytics industry. So that's kind of like a little bit, the history. So probably it was needed because, like that was the only way to progress the industry. But over the last years, from my point of view, it has come, to actually to be a very, very expensive for our industry, because, like by being a silo, by being separated from the rest of analytics, we have not been able to capture, the advances, the immense advances that have been happening over the last years on the analytics industry, because, we were kind of like in our own kind of like technology stacks and, like and formats, right? And so that's one part. But also think about like the cost, for the professionals in this industry. Like the idea that you had to call like you have to become a GIS professional, you were called like only doing geospatial and not touching other parts of data, that making that silo has meant that, on average, like GIS professionals actually earn less money than, like professionals in other analytics kind of careers. So creating that silo, now it's become very, very kind of like very obvious, how expensive and, how much of a problem it is in a way for, like for the progress of our industry and also for the progress of, the professionals in our industry. And that is one part, where together with you, like we started, like the spatial data science conference with this idea of trying to kind of create bridges, where geospatial kind of like experts could move to a data science kind of like type of roles and the other way around, right? So trying to kind of like bridge and make the connections in there. But we're still right now at the beginnings. And then obviously, now we're starting to see a path forward from a technology perspective and convergence. But yeah, but historical, like that's what has created. And now we are about to start kind of like in a way, we're starting to break that silo.
Yeah. Well, one big thing I've been talking about and hearing and having more discussions around is the question around where do you start to try to converge, right?
Yeah.
And there's a lot of different ways. There's of course, I think some of it started in, the technology to see data, visualize, or kind of visually analyze it. I mean, you have maps and BI dashboards, you have maps in, on the web. And I think that was kind of like a first step to actually say, okay, we can have these things alongside each other.
Right.
Then you start to look at the technology to actually work with or store that data. I mean, you look around, Postgres and PostGIS when I think that was kind of an early one in the early 2000s. More tools like the data warehouse ecosystem. You have the Spark ecosystem. They're all kind of starting to adopt this.
Yeah.
But what you pointed out at the beginning, I think, is where it really comes down to around, and it's probably the I don't want to say it's the least kind of interesting, but I think it's the most fundamental problem, which is this data formats, right?
Yeah.
There's this inability for geospatial data to work alongside some of
Yeah.
the more modern data structures and data formats. It's changing, of course, and I think you and OGC and CNG and a lot of folks that are actually starting to adopt it are helping to lead that. So but why is it data formats that's like the fundamental thing that could actually, tip the scales here?
Yeah. No, it is, right? I mean, like it's yeah. There's, I mean, like if you think about like any large organization that is working with spatial data, I mean, like they're not only working with the spatial data. In fact, I mean, unless that like an organization is very, very heavily spatial oriented, most of the data is not going to be spatial. And and that's why you see like you've seen the rise of like analytics platforms with products like Snowflake, Databricks, like BigQuery, and like all these really big analytics platforms have grown tremendously as the demands from organizations have grown tremendously when it comes to analyzing and making use of their data. Now, the problem is that when an organization is moving towards a much more data-oriented approach, and more analytics approach, geospatial data has be stayed separately, because you wouldn't be able to access your vector, your rasters, your trajectories from your traditional analytics engine. What you will end up having is having to ask either a GIS expert or someone in the team will become some sort of geospatial expert to be able to extract information from GIS formats and move it to the other place to be able to connect it with the rest of the data. And that in a way silo that separation in any ideal situation, what you would like is geospatial data to live together with the rest of your data. You will not want to have to make any distinction. You will want to be able to analyze it the same way. It should be just I like to say that it should be just a join away, a join on your database away. Why? Because when you have it so accessible, then the usage increases a lot. There's way less cost of duplications of data. Your analysts become much more productive. They can leverage the scalability of those analytics platforms. So in a way, I like to say that when GIS stands alone, businesses stay behind, and it really is the case. I mean, you end up with organizations that they would like to be able to get much more value from analyzing spatially the data, but the cost of having to move the data between these two silos makes it not possible. So and fundamentally at the core of it is a formats problem. So geospatial data for most of the time has been considered unstructured data that analytics engines will not understand, and that you have to do something specific with it. And that is what is now changing, and that's why we started GeoParquet initially, and the vision with it was, well, initially we were at Carto, we were working with so many of these engines, BigQuery, Snowflake, Databricks, and there was clearly going to be interoperability problems if we were to share data in Parquet format, which is a very popular analytical format. But then it became very clear that, well, not only is ensuring interoperability between the systems, but if more data is moved to a format that analytics platforms understand by default, the accessibility to that geospatial data increases a lot, and the value of it increases a lot, and the value of geospatial and spatial analytics becomes much better, right? It's much higher. So it was a very peak of when we started seeing that when you make geospatial data accessible in the right way, its usage and its accessibility increases quite dramatically, and for me that was a very clear path. If we wanted to make this geospatial industry much more widely accessible, we needed to break that silo. And started again with GeoParquet. We did a pretty big work with a group of of people defining it, and you know what, at the beginning we had to do it as an extension in terms of we had to extend Parquet with our own geospatial informative data on top of it. But now, only 2 months ago, finally got actually accepted inside, the Parquet standard format, and now Iceberg, which we can talk later, too, which means that finally geospatial data is no longer some sort of, an extension to an analytics engine. It's a fundamental data type. The same way that you have Booleans, strings, dates, you have now geometry and geography. And that moment where we're making the geospatial data type just available by default in the analytics platform. For me, it's an incredible cornerstone of our industry. It's really going to change, the reach and the value that we can provide to society.
So one thing that I think, well, there's two things, but the first one was around analytics engines, right?
Yeah,
That's a big kind of change, I think, in terms of the way we think about, well, it's been a big change in how we think about data. But for spatial data, what do those things look like if you had to, kind of summarize some of the questions someone might be asking in an analytics engine that's non-spatial? And then what are the questions that they also want to ask with spatial data alongside of that? Because those are probably the questions that, I mean, I know some of them, but and I know you do, and a lot of your customers are asking them as well. What are the questions they say like, hey, I'm asking all these questions in my analytics engine anyways, and
yeah,
but now I want to ask them and add spatial context. What do those things start to look like, and kind
yeah,
of what is an analytics engine on top of that for the
yeah.
folks that don't know?
No, sure. So you can think of like analytics engine as a product, as a piece of software that allows you to connect to data and perform queries into it. Traditionally, you can think of it as a database or a data warehouse. Most recently, I mean, the most popular way it's been, through the usage of either SQL or Python, right? And I kind of like if it's, like something like a Spark, like this Python will convert into some sort of, like programming that, will essentially scale, like the query or, like what you're trying to achieve, Same goes with SQL and Snowflake. Now these two worlds are getting very close together and so on. But think of it, like as the engine, as the kind of like underlying technology that, like an analyst will use to make questions to data, right? And especially in today's modern cloud native kind of like world, what we're seeing more and what is very, very clear is, is what we call this separation between the storage and computation. So you store your data in cloud storage in S3 buckets, or like in some systems, and then you will use an engine to actually make queries to that type of data. And that, you might be storing your own data, but you might be also using someone else's data, that is stored in another cloud storage, and that engine can talk to both places and kind of give you the answers. So let me put you a more kind of concrete example. As you say, imagine that you're like an insurance company. So an insurance company, one of their responsibilities is to look at, how vulnerable are their portfolio of customers are, to certain event, right? Like flooding, for example. So they need to check, what is my level of risk, and if there's, certain type of, events coming, like a hurricane, or any severe storms, I want to know potentially how much I'm going to be impacted or how much I've been impacted. So in a traditional analytics engine, what you will have, or organization, you will have a lot of data where essentially just your customers' data, who those customers are, where do they live, plus how much do they pay, how big is their house, what is the amount of value that you're insuring, etc. So that is just the traditional business data, right? Together with that, you might be having other sorts of information, like have they paid their the bills, all this type of things. Now, if at that point you want to look at okay, how is the flooding risk of these customers, you're going to need to bring another type of data, which is a flooding model. So I said, what is the potential of of in any place be certain level of flooding. So normally that is in the form of a raster data set in the GIS world. Rasters most of the time on the geospatial world are stored as so-called geotiffs. It's a specialized format for geospatial that stores the image of that flooding potential. Now, in the traditional world, what you will when there's this siloing effect, what it will mean, to check, to calculate what is the potential of flooding for each of your customers. You will have to extract all those customers, locations, move them to a GIS product, and then in that GIS product, intersect all those locations with the rasters, extract the values from that file about how much flooding potential you're going to have in there. And when you finish, move it back to your other system in order to be able to do your analysis, which might be an analysis, to calculate your exposure to risk, or it might be that you want to send an email to those customers that are very likely to kind of get affected by flooding and so on. So that's the traditional world. And you see, like, that's where you are like having to move data from your traditional database where you have your customers to a GIS systems just to extract information and send it back. Now, in a cloud native, and like in a format like we are like proposing and that we are like now doing, what we're looking is for this convergence of like the geospatial data with the rest of the data. So if we make that raster data set available in the same system where they're having their customers' information as just one more table, if that GeoTIFF will become just one more table in the database, and they can just do an intersection between the customer table, like a join between the customers' tables and the flooding data, just in SQL, for example, now the accessibility of the information has become way much easier. So it's much easier to use. And that's what we call looking at doing it here. By converting geospatial data into normal kind of like formats that like engines can understand, we increase dramatically the accessibility of that data and therefore the usage and therefore the value. And this is at the core of like the vision of like when we started with GeoParquet with Vector. This is now what we are introducing at Carto and collaborating with Whereabouts on something we call Racket, which is rasters in Parquet. And then you can think also about trajectories in Parquet, and then like point clouds. Eventually, we can imagine, I mean, I'm pretty sure we're going to see all geospatial data converge into formats so that they can be used within any engine, right? So that like can be used by geospatial experts, but also by non-geospatial experts, and where you don't need to be migrating between different formats just to be accessing the data. It's just, in a way, I like to say that this is finally making geospatial data be free, because it's no longer kind of like trapped into specialized formats that only few people can get access to.
I think that there's a few key points there that for someone who's listening to this that is understanding, well, what does that mean for my job and my career that
Yeah.
maybe is in the GIS sector or in geospatial. If you think of it, one of the biggest headaches I've always had is, okay, you have a customer that has a very concrete problem, right? Imagine you have a trucking company and they want to figure out areas where there's going to be, snow blowing, right?
Yeah.
There's data out there that can tell you that, snowpack,
Yeah.
density, all these different things. It's in a format that you have to extract it and move it from GDAL and do all these extra steps to get there, right?
Right.
What I think that means is, how can you as a geospatial expert leverage your skills, and you hit on a few of those, cloud, SQL, some of these different places, to become a more of a geospatial data engineer that can take that data and bring it to structures so that it can be used in those analytical engines. And I think that's a big shift in the mindset of, well, I'm maintaining GIS data, or I'm working with it in a desktop system, and everything kind of works, to now I have to kind of open it up to the rest of the world. That really at the core of it is the concept of breaking the silo. You are now taking it out of the thing that worked for so long, and you're basically opening it up so that everyone can access that. But what that does is it cuts down in the time that people actually can extract value from it, right? And I think that's the key of how all this can start to fit together, and it's a big mindset shift for our industry.
Oh yeah, absolutely. It is, and like, and there's like always going to be forces that trying to keep it like close for some different interests. But overall, as like as professionals, I mean, the idea of just kind of like participating of the larger kind of like analytics kind of like industry, and the value, I mean, like that you're providing to your employer. I mean, whatever organization you're working on, the project that you're working, it increased quite a lot if you actually can like put it in the context of the rest of like the data and the rest of the organization. So yeah, it is quite a change. The good news with it is, like, I think like geospatial experts will become much more like polyvalent. They will be able to be kind of like, in a way, data analysts or data scientists on steroids with geospatial capabilities. Don't take me wrong, you still need to have like some deep geospatial knowledge around how to model data, or how to kind of like interpret certain kind of like spatial data sets, how you do spatial modeling, like all creating, like all these things are not going away. What we are like changing is where they are being done, so that they're more impactful. So it's also pretty exciting, because it means like now the community is also has access to much more powerful tools. And we will talk more later on the AI, but like it also means that as an industry which much more future proof. I like to say that the geospatial industry for a while has been always been 5-6 years behind. Any innovation that was happening on analytics will only come like 5 years later to geospatial. And that was in part was because of this silo. Now, I mean, like you can be a GIS or geospatial like expert and be using the latest AI models, with your, I mean, the latest vision models to do remote sensing, and within the tools that are already prepared for doing that. We don't have to adapt the entire AI vision kind of systems, to work on GIS. No, we're doing the other way around. We're adapting, like GIS data so that they can work on that one, and that is going to be incredible, like new superpowers to our community. So yeah, much more opportunities from a career development perspective, also much more exciting from a pure technology and capabilities perspectives, right? And finally, like from my point of view, much more potential for impact, which is in its core, like many, myself, but like when I talk to a lot of professionals in our industry, I mean, like there's a lot of people, who join this field because of their desire to have like impact on different things, either environmental or social or whatever they're working on, and like this change is making like the work much more relevant, much more impactful. So I think it is a tremendous opportunity. But of course, I mean, there's always going to be people behind, that are going to want to call like stay things that they were before. But I don't think this is like now stoppable. It's very, very clear that there's this convergence, and it's just going to be great for everybody.
Yeah, it's funny because I gave a talk yesterday, and I talked a lot about cloud native formats, and then immediately after the second speaker, she's a scientist working on ice sheets. Very different from the stuff I do day to day.
Right.
The core content of the talk was how moving data around and data formats are difficult and painful. And if you can solve that problem, you decrease the time that someone can actually get up and running and study. I mean, in this case, it was crevasses in the ice sheet in Antarctica from hours or days to minutes, right? And
Yeah.
and that's it's so funny that it's from
That's
two
the impact.
very wide ends of our industry, but that's kind of the core
Yeah.
problem. Yeah.
And it's kind of like funny if you think about it, because when we talk about like cloud native formats, right, like GeoParquet and like and cloud GeoTiff and so on, many, and this is common from our industry, or probably maybe my own circles. We very often start from more of the technological advantages, right? A lot of people talk about like cloud native formats as being so crucial because they're very effective at only downloading certain parts of the data, and like being technologically more advanced. And that is true, no doubt about it. But if you ask me, the biggest impact is more in what we are describing in here. Is by making them like accessible to a larger audience, to where we make geo just part of a bigger thing. It is the increase in performance, in the sense of like how we make like professionals much more effective at the work, and therefore like just basically much more impactful. For me, the interoperability is incredibly much more powerful in this case than the actual like technology benefits, which there are a lot too. But don't get me wrong, I think like not everybody has like a 1 petabyte of raster data that they're analyzing every day, right? It is very sad sometimes when you say like a pretty small raster data set and someone trying to do like a simple analysis and taking them a long time, not because of computation or like just because like the formats and the whole like industry just doesn't make it easy.
Yeah.
Yeah.
It's I I've always started to talk more about the benefit of cloud native geospatial actually being for the end user. Like all of this stuff that's happening in the optimization and the formats and read optimizations and that stuff's great if you really want to dig into that. But I think 90% of people, the benefit's just going to be I can get the data.
Right.
And when talking about data accessibility or data access, you mentioned a little bit about Iceberg, which is a kind of a new piece to this puzzle. Um,
Yeah.
I'm excited about it. What are you excited about with Apache Iceberg? To be clear.
No. So Apache Iceberg is definitely one of the most exciting developments that has happened in this industry for a long time, and it's honestly, I mean, it's I'm not going to say it's a silent revolution because it's everywhere. I mean, there's a lot of people talking about it, but I think we're going to hear more and more as we go, right? But so in the nutshell, think of like Apache Iceberg, like where we are really separating this computing and storage that we were talking before. So traditionally, if you were using something like Snowflake or Databricks or like or BigQuery or like any of these engines that we were talking before, internally those products will do this computing and storage separation, so they will be very efficient on how they store and like process the data. But you as a customer, as a user, as an organization, will have to decide very much which of these platforms you will use, because you will have to kind of like ingest the data in their systems, and then they will store it in their own kind of like formats on cloud storage, on S3 buckets, and so on. And those storage kind of like systems will not be compatible. So if you were using Databricks and you wanted to use Snowflake, you will actually have to move the data from one system to another. And same if you go to BigQuery and all the different kind of like possibilities in there, right? And that puts like in a way like that was a locked in for a lot of these organizations. What Apache Iceberg comes to solve is this idea of like, no, you're gonna have like we have a common storage format and protocol to interact with that data, so that you can connect to it from any engine and get access to it and perform queries and and access the data efficiently, like regardless of who is managing that data. So I might be managing my data, organize it into tables using something like Snowflake, and then I would put like something like Databricks or whereabouts, like or any kind of like engine on top of that for certain kind of type of queries. So that separation between computation and storage, that liberation of, in a way, the storage layer is very important, because it's going, first of all, it's very pro-consumer. It's going to allow a lot of organizations to kind of like be able to try multiple engines as they need without having the need to move their data to different systems, because all of them will read from them. So that's going to, first of all, immediately kind of like increase the innovation, just because the competition is just increasing. So that's number one. And that also means like you might be able to pick up like the best capabilities of different engines for specific workloads, because you don't have to move them around. So that's in essence like in the core what Apache Iceberg provides. But there's more things. Think about like now, and our industry is very common, like almost everybody working on geospatial has to work with their own geospatial data, but also subscribing to other data providers. You might need to get access to demographics data. You might have to get to weather data, to mobility data. Almost anything around geospatial, you have to put in the context of other types of data. That's, for example, why in Carto we have this Carto Data Observatory, where we kind of host a lot of data sets that people are using all the time. So what if all those data sets were already available in Apache Iceberg 2, and now you can just make SQL queries again, like mixing, like these sources, and the data is always updated. So if I am providing you the weather data and you are combining it, with some flooding models from someone else, all the data is always updated and you can access it like if it was a single layer, like if it was a single database. I like to say that, like Apache Iceberg kind of realizes this vision of like we all live in a single database and everything is one join away. Well, now Apache Iceberg has made that possible across all the entire industry, and the response has been tremendous. Like like Databricks Databricks, I mean, like spent supposedly $2 billion, like with on the company behind Apache Iceberg. It's an open format, but it was Tabular was behind it. Snowflake has done incredible investments on it. Google, AWS now has something called S3 tables. So the adoption at the industry level is massive. And now the great news for our industry is that we've, in version 3, we've managed to make like the geography and geometry data types actually native on Apache Iceberg, which means that like now most of the engines, and there's a very big competition to be the best at supporting Iceberg, are going to add geometry and geography. So because of like Iceberg and because of the support of Geo on Iceberg, we're going to be pushing the capabilities, the geospatial capabilities, much faster than we could have ever imagined. As Scala being an extension to all those systems. So to me, this is kind of like the exciting part. We're going to start seeing many more people using geospatial data, and we're going to be able to kind of like see much better geospatial support and implementation in a lot of these engines.
Yeah. I think one of the key things to call out, Iceberg isn't like the data under Iceberg is just Parquet files, right?
Yeah.
It's or GeoParquet in that case, which is now just Parquet. But of course, what is really interesting to me is that it has that record, the transactional record of what's taking place. Like if I push a bunch of files into a folder or a cloud storage bucket, right? I'm suddenly overwriting them. But what Iceberg does, it allows me to programmatically do that with SQL and still preserve the record.
Right.
And one thing I did with this recently was there's this amazing data set around the US of US, river gauges, right? And it tells you the height and it's updated every 15 minutes. Now, what is good about that is there's live data. What's bad about it is it's a shapefile that's overwritten every 15 minutes, and you lose all historical record of that.
Yeah.
What I can do with Iceberg is I can just pull and read that in, and every 15 minutes add to this data set, which gets very large. It gets to be close to 1 million observations a day, and extrapolate out over a year. It's a lot of data, but that's really important when you want to understand, these flooding events, in these different areas, be able to replay it and understand that. But what I think you called out very clearly is I can easily port that data into any system. And when you talk about interoperability, you're really talking about choice. Like you can choose how and where you want to use that data. And by having that, you have the options of going anywhere. And in reality, data teams, beyond the geospatial world are using all kinds of different engines. You have some companies that are using, every data warehouse and every tool under the sun. That gives them that opportunity to be able to have a master data record, but still connect into all the different systems. And we've never had that in geospatial before. We really haven't. So
no. And there's this derivative kind of like, as I was pointing, is like the level of competition that we're going to start seeing with these engines means that like they're all going to want to have to excel as being the best at working with with Iceberg data, right? So because if not, you will move to the next engine, right? If the one that you have is slower, you will move to the next one, which will push the capabilities of all of them, to kind of really be able to match. And that's something that we never had on Geo. Like the geospatial performance on certain engines was pretty poor. Now you're going to see a tremendous push on all of them just to be better so that they can stay competitive. So for us, being native means that now we win from that competition. Like we are. So I think like the next year you can expect that you can see like a much faster geospatial on Snowflake, Databricks, like BigQuery, Redshift, like Trino, Wearable, like you're gonna see a ton of innovation just to ensure that they match or that they excel at geospatial. And that's something that we're going to benefit a lot as an industry. And that's just also to make it clear, we started with vector geometries and geographies, points, lines, polygons, but we're not stopping there. With Racket, and the idea is to also try to standardize rasters in Parquet, in Parquet and in Iceberg, so that those can also be part, just exposed as tables. And so it is, with trajectory data, objects moving over space, or point clouds. All that geospatial data, all that convergence has to come. And we're going to see over the next years more and more standardization in that part. In fact, that's actually one of the parts that I'm investing the most myself, is just because I've seen already the impact, when you make, geospatial data accessible in this way. Well, now we want to make all geospatial data accessible this way.
Yeah, it's It's funny because I've literally had this same conversation 5 or 6 times with people across every aspect of our industry. So when you hear the same thing quite a bit, you understand that there's something big going on, and I think
Yeah,
that's important to call out. The other piece is when we talk about data access and getting data, specifically geospatial data, in more usable formats. There's one big thing that's consuming lots of data right now, and that's AI, right? And when we specifically, I think, talk about AI, is this: how does spatial data interact with these large language models and their kind of ever expanding scope? That's a huge area that I think is untapped, and I think just we're just starting to scratch the surface of what it really is. I know, and if you've played around with some of the, the large language models, they have some spatial awareness. They know where things are roughly into relation of each other, but they can't really be used to ask detailed spatial questions about what's happening right now. So how does AI fit into this picture,
right,
and why is data access going to be really important for that?
right. Yeah. So yeah, it is massive, right? I mean, like in first, like in its core, I mean, like I like to say that like AI is gonna be it's a great, like in uh, it- it's great at increasing the accessibility into anything analytics, and that includes geospatial. So, I mean, we all probably seen it already. I mean, like just running any spatial SQL, it used to be quite tedious. You had to kind of look at the references and so on. I don't know. I mean, like these days, and like all these LLMs are amazing at like helping you out, like in code, and that includes like Geo, and that goes for SQL, Python. So obviously, there's already an impact that we are seeing on geospatial, in productiveness, just because of like what we've seen on impact on code. That is very clear. But there's other angles, like you mentioned, right? I mean, like the models right now, for example, the vision models are not as effective right now at like understanding geospatial data. In fact, you can give it a try. I mean, like at understanding and at producing. At producing, for example, like there's a lot of like now ChatGPT, OpenAI has a very strong like, and so does Google on vision and Emacs models that allows to produce. Ask them to make you a map of Madrid. I mean, the shapes will look weird. So it's clearly the models still do not understand geography particularly well, at least on the visual part of it. And in fact, one of the things that we're doing in Carto is we are doing an analysis. We're creating a benchmark around that, how good our models are interpreting maps, right? Because we need to be able to assess that and see how they are evolving, and they're gonna get better. Don't take me wrong; that's very, very clearly, gonna get better. Now, to your point about like how this is going, how we can make use of it on our industry, and how it is the connection, we're gonna have to make it part of our tooling, right? And this is in part what is happening now. I mean, like products like Carto and others, like we're starting to add, like AI to help on features, to be more productive, but also, to create new experiences when you're doing analysis. So the traditional paradigm of, like choosing, like layers, the GIS kind of like paradigm of like, let's look at layers, visually analyze, like then do kind of like type of like analysis. That is very, we know that is changing. And often you hear, like AI is the new UI. So a lot of the paradigms are going to change on the way that you question the data and so on. And you pointed right. I mean, like if you ask, ChatGPT today, like for some spatial analysis, will probably give you pretty bad answers. But if you use ChatGPT together with a tool like Carto, to actually kind of perform the analysis for you, all that systems, then it becomes really, really useful. So we're gonna see similar kind of like a situation as like something like Cursor on for software development, which has been very, very effective at finally kind of like tapping into how we can use AI effectively for software development. And now with agents in other industries, the same transformation is happening. So by connecting the AI with the data and with the right tools, like that's where you see really transformative ways of changing, how we've been doing geospatial. I think that is one thing, and that's on one part on the expert who is actually using the tools and who is doing the spatial analysis. Now, the other part of this is the accessibility of these results. I mean, just imagine our industry, how many geoportals, how many websites and like and dashboards where you go and find your insights, kind of like make your own. Well, all of that is changing now very rapidly. As we kind of like as experts, we are going to be enabling more an experience. And we started, with Carto AI agents on the concept of, like, how can I enable, like a geospatial expert to create an agentic experience to a non-spatial expert so that they can talk in natural language and in voice or texting and be sure that the answers make sense from a geospatial perspective. So I think this is at this moment where we really need, like the experts to define the context so that the model can actually answer proper questions. So an example of that, we worked, with a lot of companies on, for example, on out of home advertisement. And if you look at, like at the tools to design your own campaign about where to buy billboards, they kind of like the interfaces where you can, like look for inventory has, I think it's around, like something like 60,000 options. You can activate different kind of like segments of people, and you will see on the map different combinations of all of that. Now, you have to know a lot to kind of use this type of interface, to be very effective. Now, but if you put an AI on this and you tell the AI and you allow it through RAG and through different kind of like toolings in an agentic way to say like, no, you got to answer in this way and you got to look at these sources, and this is how you eliminate not only hallucination, but like you can really guide the agent to really help the final user get the answers that they need. And when they cannot, that they can also say like, sorry, these GIS systems cannot answer that, which is also as important as answering the question, is knowing when you cannot answer, when you don't have access to the information. Like so that's that kind of relation between the AIs and the GIS experts producing the experience is something we're going to see much more, and that's how we really going to make AI much more effective at democratizing access to a lot of these analytics. The idea of like you're just going to make any random questions and it will just come with a final answer. I mean, maybe eventually we'll have like the ultimate machine for everything. But these days, what we're seeing more effective in geo and also in other industries is these control experiences where experts really guide the AIs to kind of do the right things. And that's going to be very transformative.
Yeah, there's a huge component of how do you get data in the right format that's really usable
Yeah,
for, just for, the LLM to start to read. Like you can't just dump a shapefile in there and tabular data and expect it to figure out what to do with that.
exactly.
It also has to have some sort of spatial reasoning where it can ask a question, how far is this thing from this thing, or is there a cluster here, or stuff like that. But
Right.
then there's that big layer of, you know, that expertise in the middle about understanding the problem, the context, what's happening there, the spatial thinking that we all study for a long time to understand, putting that into something that you can give your knowledge to this tool to help it scale out. I understand there's a lot of concern about AI taking jobs. I think it's actually going to make your job reach out and have a lot more value. And I think like that's the big thing is it's I know it can seem hard to look at it that way, but
Right.
that's that we can really help scale. And that's a bigger conversation that we need to have as well. But
No,
um
this is funny.
yeah. So yeah, any other thoughts on kind of these big convergences between the data access, leveraging AI and geospatial, kind of
Yeah.
what else is on the horizon that from your perspective?
Well, I mean, like if you put these 2 points in connection, right? I mean, like the rise of cloud native kind of like formats and like these open formats and GS and breaking the GIS data silo. If you connect that with the AI, in the sense of like we're saying, like breaking the GIS data silo is good for organizations, for society, for people to get access, but it's also very good for AI. So, like it is right now the very, very important moment that we have to make geospatial data as widely accessible as possible. So, among other things, so that the AI models can actually use it and can resonate with it as well. So, by breaking our own kind of like silo and making it part of that, we will make sure that like AI will tap into it and we will benefit from this industrial revolution that is happening these days, right, with AI. So I think, like, it is a very good point. Like, these two topics are very interlinked, right? Because they're gonna be very much, like, one, like, enables the others. If we want to make, like, AI, be good at geography, we have to kind of really make it accessible that way. So we're very excited about that. We're starting to see, some of these on geo AI models around remote sensing, but I think we've only kind of scratch a little bit the surface as well as possible. Very excited about, some of the capabilities now around kind of like increasing resolution. You've seen, like, AI approaches to increase the resolution of your images. That's a very, very now common pattern. Well, the same is going to happen around your kind of like demographics, spatial demographics analysis. We're going to see the same impact in there. And if you think about, like, how much more precise kind of like the models are going to get and so on, it's an incredibly exciting time. I mean, like, I'm not going to say that, like, we've discovered a tremendous amount of new data now that we can make, but in a way it is. I mean, like, AI is going to be able to kind of like increase the resolution, the quality of the data, and it's going to enable a new type of GIS that we haven't been before. So I think it's an incredible, exciting time at that, and, like, it's in the hands also of, this interoperability around this open format. So I think those two things will come very well together.
Yeah, it's an exciting time, and I think for folks looking at to understand where to go, understand that using your spatial thinking and bringing it to models and places like this is key, but also preparing data in these formats and being a key player in helping unlock this is going to be really help propel us. I think it's the next big boom for geospatial. And if we do it right, I think it gets to where we ultimately want to go, all of us working in the space, which is help people understand the world better. And if we can do that, I think we've hopefully done something right and left a little bit better legacy, beyond that. But yeah, Javier, thanks for taking the time. Always good to catch up, as always. And I mean, I know we'll be seeing you soon, and definitely with all the stuff we're collaborating on, it feels like like the good old days again. So
Yeah, no, but big time. I mean, I also want to kind of make the case, like, if a lot of this interest around it, there's a number of conferences, like, if you want to learn more about this, like, one of them being the Spatial Data Science Conference that we ran in London and in New York, and also the Cloud Native, the CNG kind of like conference is also going to be a pretty good place. So if you wanna be part of this Scala revolution, like, there's some very good, like, now, I mean, you're doing a great job now with your channel and your content, but like, overall, like, in terms of conferences, I think there's a lot to read there. So I'm sure we'll have more possibilities to kind of connect on these topics.
for sure. All right. Well, it's always a pleasure, and yeah, we'll talk soon.
Thank you, Matt.
All right.